Welcome to New England Hyperbaric Oxygen Therapy. I'm just going to talk to you for a little bit today about the mechanisms of hyperbaric oxygen therapy and how it can help you heal. Hyperbaric oxygen therapy is elevated oxygen plus elevated pressure within a chamber. Here you can see a little bit of an increase in, or a major increase, I should say, in brain activity after hyperbaric, which creates healing and restoration of brain cells we call neuroplasticity. Here's just a picture of the chamber. Here's somebody inside of it. Here's kind of what some of them look like. Those are the milder chambers. And you add oxygen and pressure and you breathe, you get advanced healing power. And it's pretty remarkable how it works, and we're going to talk just a little bit more about that. Hyperbaric has two major mechanisms of action. We're able to, with hyperbaric, with the pressure and the oxygen, we're able to actually increase the oxygen concentration within our blood plasma, our cerebrospinal fluid, and our lymphatic tissue as a direct result of that pressure. Normally, it's only carried by red blood cells, oxygen. Okay, so that's the really important thing to understand there. We'll talk about that next, but it's a different way that we're delivering oxygen now to our tissues. We still have the regular way we do it, but we have another way. We're also getting the modulation of gene expression due to the increased levels of pressure and oxygen. And the gene expression is really important because what it does is it releases a tremendous amount of growth factors that are important for growth and healing, while also suppressing genes that would activate inflammation, chronic inflammation and cell death. So really important mechanisms here, and those are two of the ways that we really get these powerful positive physiological benefits from chamber that you hear so much about. The normal physiology of how we get oxygen to our cells is that, of course, we breathe in, it comes in through our lungs and goes to these little air sacs within our lungs called alveoli. And the oxygen then diffuses across a membrane, as you see here, onto a red blood cell, okay? And so red blood cells carry oxygen. That's what I really want you to get from this. And you can see that up here. That's what we're saying here. The molecules attach to our blood cells, and that's how they get to our tissues. And there's there's a little bit in our plasma, but there's not many. So the plasma is all the stuff around the red blood cells. Anything that's white is in within this blood vessel is plasma. So it's greater than 50%. And oxygen goes from a high pressure to a low pressure, and that's how it gets in there. But that's how it goes. So we can resuscitate people because we don't use all the oxygen in our lungs, so we have a lot left over. We actually have about 75% of our oxygen left over, so we have a lot of ability there. And when we're looking at the red blood cell count in getting oxygen to our system, we only have so many red blood cells, so that's called our carrying capacity, and we're typically at our maximum carrying capacity for most of us. So just breathing in pure oxygen and these other things deep breathing aren't as helpful to actually get more oxygen to our tissues. And we really need a method of the hyperbaric oxygen to be able to do that. So here you see what happens as we go into hyperbaric oxygen therapy and increase that pressure is that oxygen goes directly into the plasma, or the fluid around our red blood cells. And you can see all these oxygen molecules. They're actually very tiny. Each red blood cell can carry 1 billion oxygen molecules. So they're very small. And, you wouldn't be able to see them. But we can get them within this plasma in high concentrations because there's not much... there's a ton of real estate for them, and there's nothing in the way. So with that pressure, as we increase pressure, it directly increases the amount of oxygen that can dissolve into our fluids or to our plasma. And that's called Henry's law of gases. So these are just physics laws. That's how we're able to do all these things. It's just physics. It's just like gravity. You know, if you pick something up and drop it, it's going to fall to the ground. If you increase pressure, you're going to increase the solubility of a gas into a liquid. In this case, it's oxygen. So you can read more about that. But that oxygen, why we want all that oxygen in our systems, because that's what gives us energy. That's what creates energy for repair. And we need that for the regeneration and growth of cells, tissues and organs. That elevated oxygen also stimulates what we talked about earlier, that gene expression that results in growth and healing while reducing inflammation, which is something we'll talk about right now. We'll talk about that later. So that's a gene expression, right? So one of the main actions of hyperbaric that is responsible for majority of healing is through the effects of its genetic expression. So basically, how does it impact DNA? And how does it impact DNA so that it codes for blueprints for healthy things, healthy hormones? And so these healthy hormones that it codes for, we call growth factors and other things, and it stimulates this release of these growth factors that really repair and heal our tissue. And we also get anti-inflammatory hormones that are activated, which reduce inflammation, as you can understand. Simultaneously, we're getting the release of pro-inflammatory hormones, and we're suppressing programmed cell death. So we're suppressing hormones that would increase inflammation cells, and we're increasing hormones that would create growth and repair and anti-inflammatory mechanisms. And this actually goes on for quite a while. So it lasts a lot longer than the oxygen in our system, and it goes on for about a day or so. And every living organism, from algae to humans, is sensitive to oxygen and pressure changes. I mean, we're all there. Hyperbaric just tricks the body into turning on good genes and turning off bad genes through this normal mechanism of pressure, and it's occurring throughout our body on a daily minute to second basis. But we amplify it with hyperbaric, and that's the key. So we can amplify this really good genetic expression and really benefit in so many ways, that from increasing new blood vessel growth to increasing brain cell connections and growth and healing, known as neurons, and that's called neuroplasticity. And we can really do a lot of work with that. So the body, we're just using the body and kind of amplifying its natural mechanisms. Here you can see what I just really want you to see here, and we talked a little bit about each red blood cell can carry 1 billion oxygen molecules. But when you get these high concentrations of oxygen in the blood plasma, or like we said, not the red blood cells, but in the plasma, it actually pushes oxygen farther into your tissue, as well as the pressure that's within our blood vessels from the hyperbaric actually pushes oxygen deeper into our tissue as well. But it doesn't just work on oxygen. It actually pushes the waste material in the surrounding areas in and out of our blood. So basically, in and out of tissue, into our blood and lymphatic system to drain out. So it allows our body to detoxify, and that's really important because we get this buildup, and it creates a lot of oxidative stress and these different things that aren't good for our cells, and so we want to reduce that as much as possible. So detoxification is really an important aspect of hyperbaric that I wouldn't say it's underlooked, but it's just not something we talk about as much, but it's really important piece of it, and so I want you to understand that. For the genetic expression we talked about earlier, we've actually identified over 8,000 genes that remember, each one, 8,000 genes in every cell. So that means multiply however many cells you have times 8,000. That's how many genes are getting affected with hyperbaric. So this is within the nuclei, or the brain of our cells, if you will. And once again, we talk about the modulation of the gene expression, flipping on gene signals that promote growth factors necessary for regeneration and development. An example of this is new blood vessel formation, and suppressing the bad things like inflammation and cell death. I'm just going to flip ahead to the angiogenesis here, because the new blood vessel formation is a really important aspect of hyperbaric, and it stimulates all of this, and it does that through stimulating the growth factors associated with creating these new blood vessels. So the vascular endothelial growth factor is what we need for a signal to create new blood vessels. So we need signals for these things. We just, throughout the body, and that's what hyperbaric really does, is it activates genes to signal the production of the right materials. And it turns off the bad stuff. And so we create new blood vessels. That creates long-term oxygenation to our brain. You can see it here where we have new blood vessel formation. And you already see, I already drawn a little bit on there, but this new blood vessel formation that creates just long-term oxygenation to the brain and circulation is just super important. And it's happening throughout the entire body, but especially in the brain, and we really love that in those areas. And so here you can see just all this oxygen within our fluids, within our tissues, and it's just all over the place. It's in our lymph, it's in the plasma, it's in our fluids, and you can see that it's just all throughout the entire body here, where normally it's not everywhere at once, right? Oxygen is in our bloodstream, and we only have so much blood, right? We only have about 5 to, give or take 5.5 quarts. So we've got, liters there, and so we've got systems that help us pump blood where we need it, when we need it. But if we can get more oxygen to greater areas of the body all at once, we're going to really be able to really optimize our healing potential. And here we talk a little bit about pushing stuff in and out of the tissue and the blood streams, including oxygen penetrating deeper. That's that detox we talked about. Oxygen in our blood plasma, lymphatic fluid, cerebrospinal fluid. Cerebrospinal fluid is the fluid that encases our brain and spinal cord, and it really brings in a lot of important nutrients and oxygen and those types of things to the brain, and it removes a lot of waste. It's really important, potentially associated with dementia, Alzheimer's, and these other type of amyloid plaquing that occurs in the neurons in the brain. And in removing those are extremely important, kind of like a flushing system of our brain. And that's really important, and that should be happening in your sleep, but not always the case. So and that's a little bit in the brain we talked about. Here's a cool thing that shows the difference in metabolism and circulation after 40 hyperbaric treatments. And this is just brain changes that are occurring, right? This is oxygen to the brain. These are changes in metabolism that are occurring in the brain, which is the brain healing. It's the brain changing. It's called neuroplasticity, which you can read right here, but it's the regeneration and reorganization of new neurological connections between our neurons, between our brain cells, strengthening our brain as improved signaling ability and control over itself in our body, reducing symptoms. And so that's super important. Wound healing. It heals the wounds for all the reasons we just said. It's the gene expression right here. One thing we haven't talked about is the release of stem cells. And so it actually releases exponential release of stem cells, which are blank cells that can turn into anything you want. It's like a wild card, right? So this wild card can turn into anything you need. And they're really important for healing. Of course, the increase in oxygen is super important for healing, for that energy. We're increasing fibroblasts, which increase collagen factors and reduce scarring. Really important in healing, and of course, post-surgically, for different things. We actually strengthen our collagen and increase the flexibility of our tissue through the release and the hydroxylation of these proline and lysine factors. So stimulates osteoblasts, which are the expression of growth factors for forming new bone and repair. So if you've broken a bone and you want to heal faster, we've seen that with plenty of patients. And decreases cell damage by reducing oxidative stress. So it's going to make your tissue be able to heal a lot faster. And here's some of that neuroplasticity we talked about before, but it's that gene modulation. We're releasing, here we talk about trophic factors, trophic changes, which are helper molecules. Get that out of the way so you can see it. But they're helper molecules that allow a neuron to develop and maintain its connections with its neighbors. Without these trophic factors, brain cells may die. But they're helper molecules, and they allow our neurons to grow and connect. And that's really, really important. I just want you to really understand that. And that creates brain changes. It decreases neuroinflammation through the gene expression, which is really important for healing. Increases that neovascularization, or growing new blood vessels in there, like we talked about. And improves the health of our autonomic nervous system, which is like a balancing system that allows us to send blood flow where we need it, when we need it. And that's kind of what the autonomic nervous system is, really important for that. People with brain fog and different types of things can experience, experiencing that lightheadedness and dizziness from autonomic nervous system. And the stem cells we talked about, and decreasing inflammation, which is really important. Acutely, we're able to decrease blood vessels size and prevent leakage and swelling. In anti-aging, there's more research on this, but basically we're increasing telomere length and decreasing senescent cells, which is really important. Thank you for listening, and I hope you learned something.